Yeah, welcome everyone to this third edition of MoroccoAI webinars. So yeah, MoroccoAI, as you already know, is an initiative led by experts in Morocco and abroad to promote AI growth in Morocco and build a strong collaborative AI community both locally and abroad. And you already know, I mean, a lot of our activities like the last conference was really a great success. And we are starting to share now the videos of the conference. So please get in touch and please, follow us on LinkedIn. You'll see posts about the videos of the last conference. And since you are already here, you know already about the AI webinar series. So if you want to watch the last webinars, the previous webinars, of course, they are all available on our YouTube channel. So please, check them whenever you want. And today, we are very pleased actually to have Loubna Ben Allal. Loubna, to just read a short biography. She's a machine learning engineer in the open source team at Hugging Face, working on code models. She holds a master's degree in mathematics and deep learning from École des Mines de Nancy, and she graduated from the MVA in French, master program at ENS Paris-Saclay. We are very happy actually to have you, Loubna. And the title of our presentation will be Building Open Large Language Models for Code. So again, very happy to have you with us, Loubna. And the floor is yours. I'll give you.
Thank you. Thanks a lot for the
to share your screen.
Introduction. And thank you again for the invitation. It's really a pleasure to be giving you this webinar. And thanks for all your effort to try to advance the AI expertise in Morocco. It's great. Okay, I will share my screen. Cool. Should be seeing it now.
Yeah, perfect. Excellent.
Great. So today I will be presenting to you a little bit the field of code generation, and in particular on the project I'm involved in, which is Big Code. We were trying to develop language models for code, but in the open. I'm also going to be presenting Santa Coder, which is a model that we released recently that does code generation. So the field of machine learning for code, very exciting things have been happening in the past 2 years. This was mainly sparked by GitHub Copilot that you have probably heard of. It's here on the left. It's a service that can generate code for you. So you can give it function signatures, doc strings, and it can complete the function for you. You can even write instructions in English. It can generate like whole code blocks for you or classes, and not just in Python, but also in other programming languages. So this is a service released by Microsoft, which is backed by a model called Codex by OpenAI. And this model was very interesting because before that, there were some code generation models, but they were not very good. They were small and the performance was not great. So when Codex was released, it was way above everything else that was there. So yeah, and up until now, it's still the best thing that is open that people can use. There's also another interesting thing for code generation that you have probably heard of. It's ChatGPT. So it's like a chatbot that can answer your questions, but it can also it can lead conversations in English, for example, but it can also generate code for you. It's more conversational. You can explain it. It can say if there are bugs or stuff like that, which is also very exciting. So these two models were actually developed by OpenAI. Other companies also try to develop their models, like DeepMind. They released a paper about a model called AlphaCode. So this model is kind of similar to Codex. It was also trained on code data, but Codex is more for like day-to-day programming. AlphaCode is more focused on competitive programming. So they first trained a model just like Codex, but then they trained it further on competitive programming data from like LeetCode challenges. And they managed to get a model that was kind of decent at these challenges. It was at the top 54% of the participants in Codeperforces, which is a programming platform, a competitive programming platform. So yeah, there's also another model called Code Whisperer, which is a service by Amazon. It is kind of similar to Codex. And why these tools are interesting, they're not very good to replace programmers, but they can really boost your productivity. I personally use the GitHub Copilot. It's very good, especially at repetitive tasks like writing unit tests or documentation. And this can like help you become more productive because you don't need to manually implement everything. And Google did a survey of like a small tool that they developed internally to do code generation. And they observed like 6% reduction in the number of iterations you have to do to the code you write. So yeah, 6% can seem small, but like if you have hundreds of thousands of employees, that's saving you a lot of time and money. So yeah, very exciting things are happening in the code generation space. But yeah, there's always a but. All of these models that I presented are actually, some of them are behind the closed API, and some of them are not even accessible to use, like AlphaCode, for example. It's internal to DeepMind. No one can really interact with it. As for Copilot, we don't have the model, and you have to pay if you want to use their service. So yeah, the API is like closed, and the model is also not open sourced. So let's say you want to take a code generation model and you believe your code is better. You just have like some specific criteria that you want it to learn. So you want to train on your specific data. The model is not released, so you can't fine tune it. The data is also not released, so we don't really understand what went into these models. There's often like 5 or 6 sentences in the paper explaining how the data was built, but that's obviously not enough. So, and you also can't like try to reproduce it because there's no code base, no data, no model. So yeah, this is actually very sad. But luckily the open source community released some models. So yeah, there are things to be proud of. For example, Cogen released Salesforce released Cogen, which is a code generation model that is very good. It was actually at the same level of performance as Codex model that was on the paper for OpenAI. And Facebook also released Encoder, which is a smaller but also good code generation model. So the models that are like in pink are the ones that are open source. At Hugging Face, we also released CodePirate. So yeah, very exciting things are happening, and models are now released. So people can use them for their own applications and fine tune them. So if you already have some open source models, what are the remaining challenges? And why am I giving you this talk today? Everything's already solved. So there are actually a lot of challenges that we still need to solve for the code generation models. Some of them are like technical, some of them are legal, and others are ethical, and there are like many other types of challenges. So before I present them to you and I show you the tools that we've developed in BigCode, I'm gonna first like try to do like a very brief explanation of what a language model is, so people can follow, and also what data goes into these models. So first, like these models are called language models. Like they can generate text, and how they usually work is they try to predict the next word based on the previous ones. For example, if I give it it predicts name, then I give it my name, it says is, and then Loubna. It will probably not predict Loubna, it's not the most common name, but yeah, just for the sake of the example. But yeah, these models, you feed text, and then they try to predict the most probable next next word based on the previous ones. And this is how they generate like text that kind of looks natural. It's not always like the word that has the highest probability that is predicted, but there are like some strategies to try to have some kind of coherent text. So this is what a language model is. And it's basically a neural network that uses a type of architecture called a transformer, which has some specific components in it. And most of like the language models that we use nowadays, they also use the same architecture. And this architecture can be like sequence to sequence, which has like 2 different blocks, or it can be an encoder, which is one type of blocks, or a decoder. Today, I'm going to be focusing on decoders because they are the type of models that are most popular for code generation. So a decoder is just like the example that I showed you. It does like left to right generation. You give it some text and it generates like the next most probable text. So for example, if you want to generate code, here you can feed it a sequence, for example, a function that you want it to implement, like how to add two numbers, which are A and B. And then you give this to your model, which is a decoder. And then your model predicts the completion of the function, which in this case has to be A plus B. So yeah, that's basically it. You have a transformer model and you train it on data that contains code. So this data, for example, you can get it from GitHub. We have lots of open source repositories. You can take the content that's inside and you feed it to your model. And the model will try to learn the patterns and associations to be able to generate new code. So it's not always very similar to what it has seen during the training, but it can be very different and kind of novel. So now let's go back to the challenges of training code generation models. So first, like the information about how the data sets were made to train these competitive models is like very small. For example, from the papers, which are usually like 10-page papers, these are like the sections in each paper that explain how the data set was created, which is basically not enough. And basically, they all share the same idea. You have to scrape GitHub for code. You find like the open repositories, and then you take the data that's inside and you convert the script to just like text and you train the model on it. But if you go to GitHub, people usually specify a license for their repository if it's permissive or if it's copyleft. And based on the license, there are some restrictions that you have to follow. So for example, copyleft licenses should not be used in the training. Since we don't have the data that went into these models, we don't really know if they did include only permissive or they also include copyleft licenses. And even for Codex, people found that it did include a lot of copyleft data, and there's now like a lawsuit against them. And they also say that you have to apply some filters and heuristics to like remove the bad quality data. And yeah, the data sets are not released. So there's very little you can do about that. Another challenge, like based on the technical side, is that all the open source models that are released, even CodeGen, which was at the time very good and at the same level of Codex model, now they are kind of outdated because the current Codex API, because like OpenAI, they train Codex, but it's not available. They just have an API that can query the model. And now if you take this API and you try to compare the results to open source models, it's just so much better. It includes more programming languages. So up until now, we don't have any open source model that is compared to that. It's also very expensive to train these models. It can be easily like hundreds of millions of dollars to train something similar. So yeah, like academics and people in research labs can't easily reproduce this. And also, we don't really know how to filter these data sets to only keep the data that's really going to help the model understand how to code. The architecture also, we usually like just take the same architecture that we use for natural text, but maybe we can introduce some changes that are more adapted to code models. One other interesting question is, how do we evaluate these models? So let's say I train the model and now I want to know if it is good or not. If I want to just do it qualitatively and look at the predictions, that's not very efficient. If I want to do it like we do for natural text, to have like some reference solution, for example, I asked it to implement a function that does bubble sort, and I just compare it to a reference solution. That's also not a very good metric, as I will show you later. So yeah, this is a specific way to evaluate these models using unit tests. Another challenge is based on inference. So the end goal application of these models is to like integrate them as services that can complete people's code. So if these models, the larger they are, the slower they are. And if the user has to wait like a couple of seconds or minutes to get one prediction, it's just going to be a very obsolete tool. So you have to speed up the inference of the models so that they generate predictions faster. So these are all the some of the technical challenges for code generation models. And then there are the legal and ethical challenges. First, regarding which licenses you include in your data set. Are they copyleft with like strong restrictions, or are they permissive, which allow you to use the code and train on it? But even if it is permissive licenses, it still requires that you give attribution to the author that made this file. And even if like let's say you take permissive data and you want to give attribution, people should still have a say in whether they want their data to be included or not. Because for example, I have a GitHub repository and it's there until someday I found that OpenAI has taken it and has trained the model on it without my permission. And if I don't want my data to be there, I should have the right to say no. So these are some of the legal and ethical challenges for these models. So all these challenges actually motivated us to start Big Code, which is a collaboration between Hugging Face and ServiceNow. And it's an open collaboration. We have people from different countries who joined and just wanted to contribute. So it's very open, like we have a Slack channel that everyone can follow what we are doing, how we are training models. We're very transparent about our approach. So yeah, maybe I see there are some messages. Okay, yeah, I thought there were questions. Okay, cool. So yeah, now I can present to you like the code, the dataset that we released that's called the stack, and also the model that we released that's called Coder. So as I said, the code is an open collaboration. We have more than 500 participants from more than 30 countries. And they all collaborate together to try to advance the field of code generation. And first I'm gonna start because like we wanna train models, but first we need good data to train these models on. So like data is very important for training large language models. And so we first built a data set and we released this and we tried to have like a transparent data governance approach before we started training models. So the dataset we released is called the stack. It has like 6 terabytes of code. It's only from permissively licensed repositories on GitHub. It has more than 300 programming languages. And also it has an opt-out mechanism, meaning if people want their data to be removed, they can ask us to do so. How did we collect this dataset? First, we went to GitHub Archive, which is like an archive for all the repositories that are in GitHub. And then we kind of took like the names of all the repositories that are open and we cloned each one of them. This gave us like 100 terabytes of data, which is a lot, but we don't need all of this data. You can have like some very weird extensions and just like not very useful to train the model on. So we selected file extensions that we are interested in. And this left us with almost 70 terabytes of data. And since we only want to include permissive data, we removed data that either had no license inside, because sometimes people don't put licenses in their repositories, or either it had the license that was copyleft. And from this 70 terabytes of data, we were left with only 6 terabytes of data. So there's a lot of data out there if you don't care about the licenses. But since we did, we only kept the permissive ones. And after that, we tried to remove duplicates because we found that if you train the model on files that are very similar, even if they're not identical, this hurts the performance. So we did an approach called near deduplication, which removes duplicates that are near but not entirely exact, because the exact ones were already removed. And this left us with like 2 terabytes of data. The data is open source. It's available on the Hugging Face Hub and you can download it. It has a lot of programming languages. Maybe you can find something useful there. Regarding the opt-out mechanism, we also released a tool called Am I in the Stack? So you can go there and you can just type your GitHub username and it tells you if your repository is in our dataset or not. If it's there and you don't want it to be there, you can just fill a form and we can remove it in the next release of the dataset. Some other data governance efforts are like removing of personal identifiable information, because sometimes people can mistakenly put like API keys inside the code or emails. So we have a pipeline to remove this. We also released the model under a license that allows it to be like redistributed for academic and commercial purposes, and has like some restrictions for malware use and malicious use. So it's under the open and responsible licenses. Now it's time to present Coder, which is the model that we released recently, and how code models are trained in general. If you have any questions, don't hesitate to post them on the chat. So Santa Coder is a model that we released around Christmas, hence the name. And it was the collaboration between multiple people and Big Code helping us train these models. But Santa Coder is not the end goal of the project. It's just an intermediate step. We'll be training a much larger model and releasing it in March. But Santa Coder was the outcome of some dataset ablations that we did to try to understand how to filter datasets and which architecture to use. So it's a 1 billion code generation model. It's a decoder model like the ones I presented earlier, which is more specifically GPT-2 style. And it's trained on 3 programming languages, Python, Java, and JavaScript, with 2 variations, which are FIM and MQA that we'll present in the next slides. And Santa Coder, even though it is small, just 1 billion, it already outperforms Encoder from Facebook, which is 6 billion, and CodeGen from Salesforce, which is 2 billion. And it outperforms them on the 3 programming languages, and both in left to right generation and also in infilling. So yeah, I will show you how did we get better performance than these models, and also what architecture changes we did. The first change is fill in the middle. So the model is like a decoder, standard GPT-2 style, and so these models, they can just do left to right generations. So you give it some text, for example, my name is, and it generates the next word. My name is Loubna. But sometimes in code, you want to text inside, not at the top right. For example, here, this is an example from Santa Coder. You want to implement a function which returns all odd elements of a sequence, but you want to fill inside to generate a docstring. So this is very common in code, that you need to fill something inside and not just at the right. So the model should be able to do that. So for example, here Santa Coder generates a docstring in the middle. But technically, how do we do that? We don't change the objective. It's the same loss as the decoder model, but we apply transformation to the data set. So for example, here, the first line, which is the definition of the function, it's called the prefix. The middle is called the middle, and the last line is called the suffix. What you do in the train is you switch the positions. You have, instead of having prefix, middle, suffix, you have prefix, suffix, middle, and you add some special words called special tokens to tell the model, now you are in fill in the middle mode. So it understands that when it sees this mode and it sees 2 sequences, it knows that it has to generate something in the middle. So this is very great. It doesn't hurt performance a lot by adding it, and it's a great feature to add. Then another change we did is multi-query attention. So these transformer models, they have different blocks. One of the important blocks in transformers is multi-head attention. So it's basically different heads, different layers. And each of these heads, they have some specific weights called keys and values and queries. And usually in the original transformer model, each head has its own values and its own keys. This paper by Noam, it showed that you don't need to have different keys and values in each head. You can just share the same values, and this will give you significant speed ups during the inference, because you don't need to load different values each time. You just load one value for all the heads. And since in these models, we need to have fast inference, especially during the evaluation where we generate lots of samples, this multi-query attention has been very helpful for that. So now, regarding the dataset ablations that we did, we found that one thing that really helped the model become so much better is near deduplication. You should leave no duplicates in your dataset. It really helps that the model sees the copy only once during the training, once during the first epoch. It can be repeated for other epochs. We also did some other filtering, we tried to filter for files that only have a lot of comments inside them, because files, when they have more comments, they tend to be of better quality. So this comments filter, it's the light blue one. It was slightly better, but not so much. We also tried another filter called the fertility. It was not very good either. So near deduplication was the only one that really improved performance. We even tried filtering based on stars, because you tend to think that repositories that have more stars probably have better quality. So we only kept repositories that had more than 5 stars. but this removed a lot of data, like 80, I think 70%. And this model was like the worst model that we trained. So this is why we called our paper Santa Coder, don't reach for the stars. So yeah, filtering stars is very bad. Don't do it, guys. So yeah, this is our model Santa Coder. You can play with the model at the Hugging Face Hub with this demo. And you can also do a dataset search if you have some files and you want to see where they come from. So this tool is still a work in progress. It's not perfect. You can also fine tune it if you have another dataset that you want to train it on. There's code to do that. In my repository, there are also like some demos of models that we fine tuned ourselves on other programming languages or just on specific formats. So yeah, that was like, I showed you how we build datasets for code models, how we train them, and which data ablations we do. But now let's see, how do we evaluate them? So let's say you have a prompt, you want to implement a function, and this is the solution that the model gives you. One way, usually in NLP, we evaluate models using metrics such as exact match or BLEU. So you have like the solution of the model and you have a reference solution that you know is correct. And then you try to see if the solution from the model matches your reference solution, like how many words are exactly the same. So this model, for example, these two solutions, like our model solution is great, even better than the one we have, but the model will be penalized because it didn't store the list in another value. It also changed the name of the E to an X. So you're just gonna penalize your model for nothing. So this exact match is not very good for code benchmarks because it doesn't really capture the syntactic features of code. So instead of that, we use unit tests. Since this is code that we can execute, we have unit tests and we see if the model passes, then good. If it doesn't, then the score is 0. So in Big Code, we are trying to build an evaluation harness, which doesn't only focus on Python, it evaluates on multiple programming languages. It also can do like generation on multiple GPUs, and it gives you like Docker containers for safety, because imagine you execute some code that's malicious. So yeah, that was evaluation. And regarding what's next, we are scaling up. We're gonna be releasing a model at the end of March, which is like around 10 billion parameters. It's gonna be multilingual. We're gonna include like more than 70 programming languages. We're gonna include more data sources, not just code, but also GitHub issues, GitHub commits, Jupyter notebooks. And we're gonna release the evaluation harness. We're also gonna be doing more PII annotation to include other types and not just emails and keys and IP addresses. So yeah, that's what I had to present to you today. I hope that was clear. And thank you for your attention.
Thanks a
okay.
lot. Thanks a lot, dear Loubna. Yeah, don't worry, we'll take care of the questions. I can ask them to you directly.
Okay, cool.
So yeah, thanks a lot for this great and amazing, actually, presentation. I'm coming from the computer vision community, but I really appreciated how you made things simpler to understand. So
Sure,
yeah,
thanks.
let's go. Let's go to the questions. So yeah, I have a couple of questions actually here, and let's start with the following one. So what algorithm or which algorithm was used for near duplicate detection?
Yeah, sure. So for like near deduplication, we have like multiple files, and we use an algorithm called like min hash with LSH clustering. So you basically compute like the hashes of the files, and then you try to cluster them into groups that are similar. And so when you find the cluster, you know that these are the files that are kind of similar. And then inside these clusters, you compute the Jacquard similarity again to just double check that you're not removing some files that should be kept and not like very close. So yeah, this is how we do it. We have like a threshold on how similar the files should be. And we use min hashing, which is very popular for like trying to find similarity between documents. And we remove, like whenever we find the cluster, we only keep one from that cluster and remove all the files that are similar to it, that are above the similarity threshold. And the code is the open source. It's like on Big Code GitHub repository.
Okay, thanks. The next question is how can we fine tune Santa Tuner Coder, sorry, for a new programming language, is it like, does it need a lot of efforts, a lot of data? Yeah, of course, but in terms of efforts also.
Okay, yeah. So first for the data, you can use it from the stack. Like we have most of what's in GitHub, that's permissive licenses. And to do that, so for example, I have like open source some code to do the fine tuning. So like you just have to do the setup that's in the repository and fine tune. So it's easy to set up. You need a GPU. So yeah, it's not free, depending on how much resources you have. That says how long you can train the model. And you can try fine tuning on new languages. People did that, like they fine tuned on Ruby and they got like a model that worked decently. It's not as good as on Java and JavaScript and Python because they were in the pre-training, but you can still give it a go and try to fine tune. Otherwise, you can wait for our next model, which will be trained on a lot of languages.
Yeah, thanks for your answer. It's actually interesting also because when I saw your paper, there's a long list of authors, and all of them are actually engineers or scientists and engineers. Can you tell us a bit about this collaboration?
Yeah, so like in Big Code, like not everyone is like engineer scientists. Like usually they have a background in NLP or machine learning, but like everyone can fill a form and tell us if they want to join. We usually like accept a lot of people, and the people who are like in the author list, they help with something like, so it's kind of different. There are some people who did like a lot of stuff, others who did like smaller, but we want to give attribution to everyone. So yeah, there are people from different backgrounds. There are like lawyers who helped us like curate the list for licenses, like philosophers, like about just to trying to think about the limits and biases for these models. So it's like a very diverse background. Just this is what makes the project more interesting.
Yeah, quite interesting indeed. Yeah, let's move to the next question. Do you know of other techniques to assess the quality of our repository? As you said, yeah, stars are maybe not the best indicator, but have you looked at other maybe ways?
Yeah, we really tried our best, tried to come up with like smart ways to do things, but at the end, they didn't really help. Just near deduplication was like the best. So another thing we did is like we took the file and we tried to see how much comments are there, like the number of characters in comments divided by the number of characters in the whole file. So if you code well, you should be including comments in your file. So yeah, visually the files looked better, but when we trained the model, that it improved the performance slightly, but like not a lot. We also tried another filter, which is like the tokenizer facility, because these models, there's the model, but there's also the tokenizer. So this tokenizer, you train it on your data, it kind of gives you like a vocabulary of like the words that are the most common in the data. And if you have your tokenizer and you pass it a new file and the tokenizer doesn't really tokenize it well, it means that there are some words that are like not very common. It hasn't seen that before. So we use this metric to see where our tokenizer fails and try to remove these files. It didn't remove a lot of data, and it also didn't improve performance a lot. So yeah, honestly, the only thing that really helped was like near duplication. The rest didn't really, it gave like slight improvements, but it was not worth the trouble of doing two different programming languages.
Okay, great, simple and efficient.
Yeah.
So yeah, let's move to the next question. So yeah, this question is about the evaluation part. So do you take into consideration the complexity of the generated code when you do the evaluation? Because some of them are probably simple, some other codes are for, complicated functions. So do you take into consideration this?
Yeah, but yeah, evaluation is very interesting. Like when Codex was released, there was one benchmark that everyone was evaluating on. It's called human eval, and it had 100 like problems, and everyone was like assessing based on that, which is basically not enough compared to natural language. But like these problems are like written by like human annotators. It's like a function to complete. So human eval is like not very easy, but like not also complex. So this is like the standard one. There are some more complex benchmarks like APPS, which is, for example, for competitive programming. And if you evaluate, you can see that the scores on human eval are higher than APPS and so on. So yeah, kind of like medium difficulty benchmarks are like the most popular now. And also there aren't much because this field is very new. Like now we have human eval translated to 18 other programming languages and maybe 5 or 6 other benchmarks that are coming. So yeah, the field is still evolving.
Okay. The next question is about the difficulties encountered when training Coder. If you can like tell us. your story with Santa Coder, and probably, yeah, the training was maybe difficult, was hard, maybe sometimes some difficulties arose. So yeah, if you can say some words about that.
Yeah, sure. So yeah, first, like I think people underestimate a lot the quality of the data. So yeah, we like needed to filter the data set. It was like very large data set, so you need to handle it efficiently to not wait like 4 days before you have your data ready. So for example, for that we use like data sets library. We try to do like multiprocessing and mapping to kind of like make things faster. Regarding the train, so like we train Santa Coder, but we train like 10 other models to do the data ablations on each new data set. So yeah, sometimes jobs can fail and you need to restart that, or yeah, but like at this scale, for example, 1 billion, it's still manageable. But like the more you scale, for example, for 10 billion, you may not need to train like on just one node. It will be like multiple nodes. It can be like difficult to manage. You can have some instabilities in your model that you need to handle. So yeah, there were some challenges, but I think, yeah, we may have more next.
Yeah, great. So the next question is actually in relation with this one. What is the ratio between the time spent in data cleaning and time spent in training the model? Did you spend a lot of time preparing data and maybe less time? Okay, so that's
because like so like the model you launched the training, it takes like a week, but it's training, you're not doing anything, you're just monitoring the loss. It took time to, for example, add multi-query attention in FIM and try to de-risk it, because these are architecture changes and we don't want to have like a model that's bad just because we added one change. So it took some time like to do these architecture changes and know that they're not risky, but also the data cleaning took a lot of time to try to come up like with the filters and run them. So yeah, they both took time.
Great. We still have like 2 or 3 questions. So one, which is quick, can we use Santa Coder commercially?
Yes, like the license, it says that you can use the model commercially. The license is also like with the model. So if you want to know really the details, you can read it. And if you have questions, you can ask it there.
Okay, and the next question is a specific question maybe to Morocco. How can a researcher or engineer based in Morocco contribute in these efforts? And probably the asker is not talking just about Santa Coder, but any other efforts by Hugging Face.
Yeah, sure. So for example, for if you want to contribute like to Hugging Face, we have a lot of open source repositories. We have always like new contributors opening issues, doing pull requests. So yeah, don't hesitate to like go to one of our libraries and contribute. And if you want to contribute to Big Code, there's like a Google form just to fill, like, I think you can go to the website. Yeah, just type bigcode.org and you're gonna find the website and you have to fill a form and we can add you to the Slack channel. And usually how we function, like we're very open. Like if someone wants to work on a task, just go work on it. If you need help with compute, we can give some help. But the project is this first iteration is gonna end like soon at the end of March. So yeah, there's a month left or a month and a half if you wanna help. Everyone's welcome.
Great. Yeah. So yeah, I'm just saying that we received a lot of questions actually, but yeah, I'm doing my best. I'm doing really my best to send you all the questions to have some answers. So I do have here one question, which is really specific also to the role of an ML engineer. Engineer. So the question is the following: you are working in a big group of engineers, and how's actually the work divided by between you all? I mean,
yeah, that's a good question. Like, so I said there are 500 contributors, but this is not like the core maintainers. In the core maintainers of the project, we're just 6. So the people who are like doing the main tasks, launching the jobs, making sure the data filtering is done, are like these 6 people, and like just 3 of them are actually, for 3 or 4 are doing the code. Some are managing more the projects because it's very big. It needs a lot of management. So yeah, it's actually a small circle of the people who are like doing for example, the big tasks. But how the work is divided, for example, we have some people dedicated. For example, personally, I've been working more on like data set filtering and evaluation. And there's, for example, another person that was in charge of running the jobs for the training, another person that was in charge of like the stack data set, like updating it and also scraping it. So like the work is pretty much divided. And then we have like our open source contributors who are like helping us with like other tasks and side projects, and each person tries to ensure that like the people working on specific tasks, they get the help they need, and also we get things done on the deadlines, because we sometimes we have pretty rough deadlines and also with papers. So yeah, in general it's done like that. So it's a small circle for the core maintainers and it's a larger circle for the open source contributors.
Yeah, thanks. So I'll try again to alternate between like quick questions and long questions. So now quick question, do you write all the unit tests?
For the benchmark,
Yeah.
no, it's not us. Like writing the unit test for benchmarks like a job. For example, this multi-PLE benchmark, they had like a lot of developers, they wrote the unit tests manually and translated them. So it's not us. Someone released this benchmark and we use it.
Next question, is there a way to use Santa Coder for code language, but this time translation, like moving from Java to Python, for example?
Yes, so usually like code translation, it uses like an encoder decoder architecture, but you can, if the model is trained like on these multiple programming languages, you can also do it. You just have to write like the prompt in a way that you ask the model, translate this code from Python to Java. There's a paper, for example, called Bubble Code. They also used kind of decoder architecture and they evaluated on translation benchmarks. They actually got good performances. So yeah, you can also do that.
Okay. Yeah, so I do have here a long question. So yeah, yeah. Thanks for the interesting talk. So to my understanding, you consider code as a natural language, sequence of tokens. However, I think the code is more than that. There's a structural side to it. The code can be represented as AST, asymmetric asymptotic tree. I'm not very familiar with the domain, so please correct me. So which is a graph data representation for code. So the question is, do you think leveraging this graph-based features of the code can improve this code generation?
Yeah, so yeah, actually also when we started the project, a lot of people wanted to work on that. And actually the models that were released before Codex, some papers were actually doing that. And we actually found that like the more data you have, the less you need to do feature engineering for the data set. You just give the model more data. It kind of learns these abstract syntax trees itself. And while like trying to engineer that and use it can also be interesting, but it's also a lot of work. And it's usually just fine to give it a lot of data and kind of magically works. And you don't need to do all of that. But it's also interesting to investigate, especially for some specific cases like compiling. And yeah, it's also something interesting.
Great, yeah, time flies. So yeah, I'll take maybe a last question. I'm really sorry for the others.
No.
I have a lot of questions. So a last question about the GPUs you used, and also if you like have an idea if someone doesn't have the same resources as Hugging Face and would like to train, what are the GPUs they can maybe consider?
So if you want to pre-train, you actually need a lot of GPUs. So now, for example, I think Santa Cruz was like 96 V100s trained for like 6 days. So it's not like, it's a lot. So for pre-training, it takes a lot, but like for fine-tuning, if you have just 1 or 2 GPUs, you can just fine-tune the model. But for example, Santa Code or maybe the other model we're gonna release, if it was already pre-trained on a programming language, you don't need to pre-train it again. You can just take it and fine-tune it into a lead much less resources.
Okay, great. So yeah, thanks a lot, Loubna, for this amazing talk.
Thanks also for the interesting questions.
Yeah.
I mean, you can also contact me on Twitter or LinkedIn if you have other questions.
Great. And thanks a lot to all the participants. And please stay with us for the breakout sessions. So we'll have two rooms. One room, which is AMA, Ask Me Anything with Loubna. You can continue the discussion with her there. And another room where you can discuss with your peers about your projects in machine learning and deep learning. So yeah, thanks again, Loubna.
Thanks a lot, Ridwan. That was very fun.
Of course, I'll stop the YouTube stream.